So these are some screenshots from Akshay's talk. So Akshay did an amazing talk about using Flow with Kotlin. So I'll go in that in a second. But first of all, big shout out just for Android Stream Day in general. It takes a lot of work to put something like this on. So thank you, Rivu. Thank you, Poan, very much for putting this on. It's really cool to be able to do it, and thank you for letting me share some knowledge. So let's look at the slides so it looks more like a presentation. And so today I'm going to be kind of building on what Akshay did when he talked about Kotlin flows. Kotlin flows are part of the Kotlin Coroutines framework, or library that's available. So that allows you to do a lot of things like background tasks, multi-threading, and actors is one piece of it that's related to channels. So if you got to see that talk, it's going to be pretty related. This is actors are like, they're usually on stage in a drama or something. So that the joke here is no drama concurrency for these actors, but I'm not that funny, so that's fine. You can follow me on Twitter on handstandsam or my blog handstandsam.com. Thank you very much for the awesome intro, Rita. I'm just going to, we'll get back here to these screenshots from the last talk. All right, so concurrency. What is concurrency? Very small. It's all these things. But let's zoom in. Let's use Keynote. Let's make it look pretty. Okay. Concurrency is the ability of different parts or units of a program, algorithm, or problem to be executed out of order without affecting the final outcome. So you got all these things happening, but the final outcome is always going to be what it should be. And what this allows for, like with coroutines, doing all this background work, allows parallel execution, which means that things are running in parallel, meaning there's multiple things running at once. It can improve the speed of the system because it can be split across many things. And this can let you leverage things like coroutines or multi-processor systems like we have multi-cores on there. So concurrency basically allows for us to do all these things, but then at the end of the day, make sure that we don't affect the final outcome of what we're trying to do. Welcome to Android. I know this is Android Stream Day. That's good. This is very much a Kotlin talk, but it very much applies to Android. The reason why Flow is so important and why coroutines are so important and actors are because Android as a platform is very asynchronous. So reactive programming allows you to tie in all these asynchronous events. And this diagram is one I like a lot. It's stolen from a talk from Jake Wharton from a few years ago. But basically in the very middle with the little brackets is your code. At the very bottom is your phone you're holding in your hand. And so if you went ahead and use your phone, as you tap on things, the code is executing. Then the code might also be talking to the disk on the left to read from a database or shared preference. And then those updates are coming back. And then on the right, you're calling APIs on the cloud. So you're getting data, it's coming back, you're processing them. And then at the top, you're listening to things like Bluetooth and other things on your phone, network, Wi-Fi, everything else. And so all of these things combined are all things that don't happen in an order. They all happen out of order in parallel, and you must react to them. So it's important to have reactive code on Android. And one of the things Jake said in the talk is once you have one thing that is asynchronous, you can't do imperative programming. So once you have one thing that kind of happens in the background and goes everywhere, you need to program in that method. You can't program in imperative method, which just means one thing at a time. So reactive programming is essential on Android. And so the Kotlin Coroutines library allows us to do that. Cool. And so the answer of how you do that back in 2017 was with RxJava. So you'd manage this reactive world with that. Actually talked about how he migrated his team from RxJava 1 to Kotlin Coroutines. If you talk to the people at Google now, they officially recommend Kotlin Coroutines as the asynchronous framework to use for background work. So no async tasks, no RxJava. They officially recommend coroutines. So just like Akshay said, I would recommend going to that. A lot of the code I've been writing on uses coroutines, and it's fantastic. Of course, 1 month later is when Kotlin was introduced as the language that we could use in Android. So that's why he was talking about RxJava. All right, what are Kotlin coroutines? We've talked about it a little bit. Let's dive in more. I'm going to try to explain it in one side. It's not probably going to work out that well, but let's see if we can kind of dumb it down or make it simple enough so that we can understand. So a Kotlin coroutine is a function with a suspend keyword that signifies that it must run within a coroutine. So you see there's a yellow suspend block, and then you have your code saying go do network request. So what that means is it's going to run inside of a coroutine and return back a result. Second of all, suspend functions must be run within a coroutine context. So coroutine context kind of says when you're able to start or cancel. Basically, it manages the running of it, and you can run that on a dispatcher. The dispatcher is very much like the thread pools that we had. So it's the default one, which is for the background. There's the main one for the main thread. There's ones for I/O and so forth. So basically, you take the suspended function, you run it in a coroutine context, and then it runs in coroutine. That's how it works. So essentially, coroutines are lightweight threads. The way that they're different, though, is coroutines don't block an entire thread. You can have hundreds of coroutines or thousands of coroutines running inside of a single thread. So coroutines just have a really nice way of, when it's not doing work, it allows another coroutine to or another piece of work to leverage that coroutine to go ahead and run. So coroutines are a really nice way to do background processing to let you really do tons and tons of things at once. And like we said, they must be launched in a coroutine scope. So how do we write concurrent code with Kotlin coroutine? We talked about how concurrency means that you can do all these things in the background at many points in time, but at the end, you have your expected result of processing these things. Here's a link. I'll share these slides later, but here's a link to the Kotlin docs to basically talk about how we can deal with these things. What they mention is a few solutions that you can use. First, to do concurrency, you can use a mutex. And each one of these, I'll show just a really quick snippet of what these are. You can use a mutex. You can use a thread-safe data structure, such as an atomic integer, which will block the thread anytime you're doing a read or a write. You have thread confinement, which means you're really forcing imperative programming, right? Everything must run on the same thread, so it must happen in order. So really, if you ran everything in the main thread, then it would be fine, but your application would be really slow, and it wouldn't work the way you want it to. It wouldn't be fast. And then their other recommendation is actors, which actors can run in their own coroutine. They're a subclass of a channel, and they allow you to do concurrent code. So that's what I'm really going to be talking about today, how we can write concurrent code with Kotlin coroutines and leverage actors. So I said I'd show a little snippet of each one of those options. The Kotlin coroutines documentation said of things that you can use to do concurrent code. One of these things is called a mutex. And so what you can do with a mutex, it's kind of like the synchronized piece that you have in Java, or you can leverage in Kotlin as well. But basically, you have a mutex, which is just object. When it's locked, nothing else can execute until the mutex is unlocked. So in this case, we're going ahead and we're locking the mutex, we're incrementing the counter, and then we're done. So basically, that means when this is locked and it's executing, only one thread at a time can go ahead and do that. And that way, it is thread safe and provides concurrency. The thread safe data structures they recommend are things like atomic integers. The example here on this would be, atomic integer.increment or .decrement or get the value. And inside of there, they're taking care of making sure that everything is thread safe so you can provide concurrent code. So I talk about integers here, but there's other data structures that they have for that. Thread confinement is kind of like I was talking about, where if everything runs on the same thread, like maybe the main thread, then you'll have concurrency, but it's not a practical thing on a system like Android where everything's synchronous. So if you wanted to run something on the main thread or have it execute on the main thread, you could create a coroutine context for the main thread itself. And so what that means is when that coroutine executes, it's going to be executing on the main thread. You also have this thing called run blocking. So whatever coroutine context whatever thread you're currently on, if you call run blocking, what it means is it'll just take that thread and run everything on it without actually doing anything in the background. So that is really useful for testing, actually. So if you do run blocking, then you can go ahead and make sure that your test runs everything and then finishes, because you don't want things to happen in the background, right? If you have a test that goes and makes a network call, if you're not waiting for that to finish, your test is just going to finish and be done. So you basically want to block the thread and say, wait until this networking request is done, and now finish the test through my assertion. So, the smart person would say, hey, concurrency, you said I could just run everything in the main thread. I'm good to go. But as Jake mentioned in the talk, once you have one thing that's asynchronous, so that's happening, in the background thread or whatever, then the whole way you have to think about programming changes. And on Android, this is not a practical solution. And so it's definitely not recommended. Welcome actors. So it's the last option they mentioned in the Kotlin documentation for concurrency. Let's talk about how that's going to work. So actors are a single coroutine. So actors are a coroutine. They process messages that come in. So actors are waiting there. They have messages come in, just like when you saw like kind of the atomic integer increment and decrement. Those are kind of like messages coming in. One message saying, please increment this, please decrement this, please get the value. So it's kind of that idea, but you get to define what those messages are that are coming through the channel. Actors are backed by a channel, so actor actually extends channel. And so what this is nice for is the fact that you get the process, I think, so actually just said channels are like primitives in Kotlin coroutines, and they allow you to communicate between coroutines in a way that's safe. That's the only way that you can talk between them. And finally, actors are concurrent, because what they're going to allow you to do is, while all this background work is happening, when they're going to be processing the messages internally, it's going to happen in order, which means that you can have all this stuff happening in the background, but as long as you give it to the actor at the end, then it will make sure it processes it one by one. So here's my visualization of this. I created this, I was drawing it, I was like, this makes sense to me. And then I stepped back and I said, this looks a lot like a marble diagram. And I know the first time I saw a marble diagram, which is typically used to like explain reactive flows, or reactive code. I saw this for ArcJava many years ago. My brain just kind of melted, and I said, "Oh my gosh! Like these things are so confusing. What's going on?" So I'm sorry that I created something like a marble diagram, but I guess these are good ways of representing it. Anyway, let me explain what I did in here, and maybe that'll help you. Let me see if I can. I guess I can't use my mouse. So what's going to happen is an actor is a single coroutine, and that imperative programming thing is going to be this line that's in the middle. So it starts on it's a for loop. It's going to be running, and it's just going to process things one after one. So that middle line, the for loop, that's all we're looking at. It's an actor coroutine that processes messages. So what's happening is on the top and the bottom, messages are coming in at various points of time, but they're going to get processed in order, like it literally in a for loop, and we'll see the code. So that we get a message, we process it. And that's really all an actor is, and that's how it's able to enable concurrency. So like we said, it can process incoming messages or intentions. A lot of the code I've been writing uses the MVI, or model view intent, kind of way of developing UIs. And so I really like the term intentions. You can send in messages, but I'm going to be mixing the term messages and intention. Basically, a message can be whatever you want. In this case, I'm going to call it an intention. I'm just calling that out because it might be confusing here if I don't explain that. So in this case, you're going to have these messages coming in, the intentions. And in this case, we're actually going to be modeling it based on an app that I have. So these examples, screen. So this is my device here. I don't know if you guys can see it. I'm a Pixel 4. So on here, I've got this app. It's called Shopping App. It's open source, and there's links to it in here. There's actually a PR, and we'll be writing code for this on what we did. So we can go into vegetables. We can go down to like avocados, and then we can add a bunch. Oops. Yeah, add a bunch. On the top right, you see there's a little a shopping cart icon. If I go ahead and click a few more times, you see it updates. If I go into there, I have 17 items in my cart, 11 avocados, kale, and roses. Let's say I don't want roses, so I can delete. And as I delete, everything kind of updates, because it's a reactive stream where I delete one item from the roses. It then notifies our data store, our shopping cart, what's going on, and then I have a reactive listener at the items in cart thing on the top that actually listen to it. So I'm going to delete another white rose, and it'll go to 14 at the top. So this is the example we're using here to show off why we need something reactive and how it displays. And then we'll be going more into the example of how we can implement this using actors so that you couldn't actually have two people interacting with a shopping cart in the wrong order, or two messages coming in the shopping cart at the wrong time, because then it might cause a problem or an error. Okay, so that's the basic use case there, and I wanted to show that because the code that's within our example here does use these sort of things. So in this DAO, and DAO means like a data accessor object, it's just a way that you call basically a database in code. So inside of there, we're going to have a few actions we do. We have find by label, we have upsert, which means insert or update, remove, which means delete, and then empty. So all these things can be done. If I actually show over in my code itself, and I didn't do a good job, so we're going to go ahead and bump this up to a better appearance. Let's see, size, use custom font, size 24. Hopefully this will be it. If not, I will update. Okay, that's not exactly what I was going for. Okay, let's not do that. Apply. Sorry about this in the middle, but let's see, font. It is a lot better if I make it bigger now. So let's see here, general, editor. Apologies again. Let's give it one more minute. If I don't figure out where it is here, then we can go ahead and you can just Kotlin. Anyway, I can use presentation mode. I just really like to do it in here, and I wasn't smart enough to do this before a presentation. All right, so we'll figure it out here. We'll go ahead and kind of blow it up. But what I wanted to show you is we have this interface called a shopping cart now. So I'm going to go ahead and just use appearance full screen mode. Is in presentation mode. Cool. So this way, everybody will be able to read it. These are the things that I'm trying to model. So first of all, there's going to be a flow which emits the items that are referenced in the shopping cart, right? So whenever you see that number on the shopping cart increment, or like you're in the shopping cart and it changes, this is the flow that's being emitted. So as actually said, anytime you have a reactive stream of things that are being published, always try to expose it as flow. Then we have these four methods that are there. There's suspend functions because they happen in the background, or at least they're causing database writes, so you don't want it to be, you want it to be suspended, so it happens in the background. So the operations we can do are find by label, where you send in the label, the upsert, the remove, and the empty. I just wanted to make sure I showed you this because when you see the sealed classes that represent that, then it makes a little bit more sense. So each one of these intentions would then be sent into one of those. And we'll actually be writing the code for this a little bit later. One thing that's interesting here is one of them sends in a completable deferred. That's because this is the only one that actually does a find and then returns back an object. So we'll go a little bit into that, but that allows us to wait for the result and then pull out what it would be. Because we actually want to find something. We're not actually just making sure it goes in order. So yeah, we'll write this out in our example, but what we're doing here is we're creating a completable deferred for this item with quantity type. We're sending it into the actor, and then we're going to wait for it to finish and then pull it out. So we'll write code for that. But what's going to happen in this actor when we implement it for this use case is we have an actor that processes those intentions. So we saw that sealed class. There are 4 different types representing the kind of actions that we wanted to do here. Those come into the actor because the actor is a channel, and it's going to process those one by one. So each one of those intentions is going to process in the channel, and then it's going to find the intention it is and complete the code. I wanted to call out here that an actor actually extends send channel, so it is a channel itself. So you're able to send things into the actor, and the actor is able to emit a value, which is on a channel itself. The actors are concurrent because it's a single coroutine processing messages sequentially. So it's a for loop processing each one by one. All those messages that are coming in are queued up in process. So one of the things you might be saying is like, well, what about like basically back pressure, right? So if you have like 1,000 messages waiting. So there's things called capacity that you can give to an actor where it could even say just like only allow 1 or maybe allow any unlimited amount. So you have the ability to kind of specify what that would be for that queuing mechanism if you have a lot of things coming in at the same time. But if you look at the documentation for actors, you might say, oh my God, OMG. It says obsolete coroutines API. Like, why, Sam, you're Kotlin GD. Why are you talking about actors? They're obsolete. Like, we shouldn't use them, right? So let me go into why I'm actually talking about them. So actors do have the obsolete coroutines API on it. However, it's not to be that scary. What it means is it is obsolete. They know that something's kind of wrong with it. And so maybe they have a replacement in the future, but not right now. So if you look at the, it will be redesigned in the future, and there is no replacement yet, but they cannot be deprecated right away. So they're not going away, but still it gives you that weird feel of like, hey, like what am I going to do? Like what if they do go away? But there's a thread on complex actors on the Kotlin Coroutines framework. Roman Islerov is the lead designer for Coroutines. He's the second answer here. And what he ends up saying is, we're not getting rid of actors in the near future. We plan to introduce a more convenient API for writing actors. The existing actor function will either integrate to the new API or be deprecated with some clear replacement. Old code using it will continue to work. We don't have a complete design on the table yet, so it's subject to change. So what this is saying is, actors as they are, when they were designed, they want to do it in a better way. So what actors do and the way they are now, like, don't worry about doing them. There will be a small migration path to a complex actor when that even gets designed, right? So there's been no update on this to say that that's been there. An actor is not something just in Kotlin. An actor is just a way of doing concurrency. So there's implementations on other languages. So what they'd be doing is updating the Kotlin Coroutines framework to make it a complex actor, which can still support these basic use cases. So actors they're not going away. They're just maybe going to be slightly changing. So if you implement them and use them now for these use cases, if it's appropriate in your project, that's totally fine. So I actually got to ask him the question because I saw that in the channel, but then we had an opportunity to talk with him on a Google Hangout. And basically, these are the notes I took after asking, like, oh my gosh, are actors going away? You said it in this thread. He said, they're not deprecated, they'll remain. But original actors were designed pre-structured concurrency. However, they're not going to drop the use cases of simple actors, and they'll support them. So anyway, this is just my whole, I wanted to make sure everybody is clear that, yes, while they might change, the whole concept isn't going away. You can still write it like this, and you're going to be okay. But then I actually talked about, channels and the completed broadcast channel, how you can send things out and how those work. But they really are more primitive. So when we want to expose reactive code, we want to use flows. And one of the new things that are out there is Stateflow, like you talked about, which is really good for emitting things like state, like the state of our shopping cart. I thought you'd never ask. So I brought this up because if I am talking about actors and I'm not talking about flow and stuff, this example really does lead itself to Stateflow. But underneath the hood, actors are a really good way to make sure it's concurrent. So they're really going to blend together here and be friends. And we'll see that in our coding example as well. So what's a state flow? I actually talked about it a little bit, but it's a flow representing a read-only state that can be updatable. Only a mutable state flow, which is one that you can use internally, can be updated. Otherwise, a state flow just is a flow that emits values, or you can grab the value just once itself. The mutable state flow, like you talked about, is what you'd use internally to be able to set a value on it. But when you expose it to a client, you'd want to make sure that it is a regular state flow so that they can't actually change the value themselves. So here's where it comes into the live coding. So what's great about this presentation is, and why maybe things were a little out of order, is when I did this previously, I just showed this code that I ended up writing in the PR here. So really, I kind of went through and it didn't make that much sense. So what we're going to do this time is we're actually just going to live code this because we have the time today. I'll do a time check real quick. So yeah, we're only 23 minutes in, so we have time to do this. So instead of explaining it here, we're going to literally rewrite we're going to look at the version I did to do an in-memory version of the shopping cart DAO, and then we're going to go ahead and change that over to be one using actors and one using mutable state flow. So let's check it out. So what we want to do is we want to do an implementation of this that uses actors underneath the hood and then exposes a mutable state flow as a flow. So I'm not that great at going in and out of presentation mode, but let's see if we can do it. Can I just do this? Yeah. So in-memory shopping cart DAO. Yes. Awesome. So right now, the version that you saw, let's see if we can do it. So the version that you saw of the shopping cart DAO is our in-memory implementation. So that means if you go ahead and you kill the application, you open it again, it won't remember what's in your cart. I've used this same presentation to talk about the differences between SQLite and Room, which are both actual SQLite database implementations that you can use on the device. So there's actually an implementation in this code base that'll use Room if we turn that on. So it'll actually use a Room database. And then finally, there's like a SQLite version that'll take the SQL database. I'm going to just operate today, just for simplicity's sake, on the in-memory version. So I'm going to walk through you now like what I had originally implemented for an in-memory version. So first of all, the data structure here wasn't ideal, but basically what we want to expose is just like we had in the app. So it would be like the name of the string would be avocado, and then it would have, it's a map. So the item with quantity would then be the item itself as well as how many. So this is what this is going to allow us to do is look up these values by label, which is this first thing, and then get the item itself. So it's going to be inside of here, like an item is, avocado with the image of the, the URL and then a link that went out to it. So if we look at this in-memory version, this is really the data object that we have backing everything. So we have the items in the cart, and we want to go ahead and update that, and then we want to emit the new values with this channel. So this is older code that didn't use flows, so it just uses this completed broadcast channel to emit the latest value upon subscription of our item with quantity. So in the very beginning, I actually just emit an empty list because I don't have a value. But then I go ahead, and this is the in-memory version. If we went ahead and we did an upsert, what it would do is it would go ahead and find this value in the cart, and it would set it in. So it basically just adds it into the map, and then I'm going to send manually out to that channel, hey, here's the new sorted list of items, go send it out so that everybody listening in the code can get the new version of it. So that's pretty much how it's going to work in here. Like if you do a find, we don't have to go send an update. We literally just look in the map and say, hey, give me the item for this label. So find me avocado. Otherwise, when we actually modify things like updating a value, here we'll do a remove for that item. And then after that, we'll actually go ahead and then do a send to the channel to send a new value going out. And empty does the same thing, clear. So if you see the commonality here, anytime we modify the data, here, here, and here, we end up doing a send to the channel. So we send out that new sorted list, And so that's going through this channel that everybody's listening to, and they can go ahead and consume it. Now, I did make this private because I did do a little bit of migration to Flow. As actually said, you don't really want to expose these. I had originally, but since I did update this, I actually now expose it. I override that initial interface, and I expose a channel as Flow. So this is an operator they give us so that people can subscribe to it as a Flow itself and use all the operators with it. So yeah, well, underneath the hood, it's using a channel. But now let's take this and let's actually go ahead now and implement it with actors in Stateflow. So I'm going to go ahead and go back to the normal view so I can copy a file because I don't know how to do it from here. We'll go ahead and project. I'm just going to do a copy paste of the same memory version. So we're going to call it an actor shopping cart, actor Stateflow shopping cart down. All right, so let's go ahead and make this a full screen again, so everybody can see it. Appearance and enter presentation. So this is the actor version. I'm just going to leave. I know he said make sure you write comments, but in this case, I'm going to move that so that we can read this a little better. We still are going to have everything backed by, let's see. All right, let's get started. Just, what I want to do first, and this, I'm going to move this stuff to the bottom so it doesn't get distracting. All right, so we have these four functions that we want to be able to do, or four things that we want to be able to do. We're going to find, upsert, remove, and empty. Like we talked about before, we want to send in messages to this actor. So I'm going to go ahead and create an intention. So I'm going to call it sealed class intention. And this is live coding, so forgive me. Sealed class intention. And then what I can do inside of here, I can say other things. So I can do like an object, and I'm going to call one. Actually, I'll start with the top. So find by label. So we'll do a class, find by label, and inside of there, we'll send in a val of label, just like we have down there, which is a string. And then we'll end up sending in a deferred. So let's leave it like this for now because it gets a little complex to do it. So next class, we'll do an upsert. So right now, what we basically did is this is now replaced by this, or will be. And now we're doing an upsert with an item with quantity. So really, we could just kind of copy this if we wanted. So this we want to call an upsert because it's a sealed class. And sending here, we'll make it a val item with quantity. The important thing we're going to do if we're subclassing a sealed class or creating one is you have to make sure you you extend it. So if I go ahead and do that, I'm extending the intention. So now for the sealed class, I have two different types. So we'll keep going. We have remove and empty. So remove takes it. Actually, this is going to be super easy. We'll just do this. So remove. I'm just going to do it this way. And then finally, we have empty. And then we'll just do object extends. And this is going to extend intention. All right, so remove, let's finish cleaning that up a little bit. That's going to be a val item with quantity, and that needs to implement. All right, so now we have 4 intentions, and I'm just going to call this, we could also call these messages. All right, so these are the messages that we're going to send into this actor so that when we modify the data, we're going to go ahead and do it concurrently. So one thing that I'm going to do, instead of having this items and list being a map, I'm going to go ahead and change this, and I'm going to make it a mutable Stateflow. So let's go ahead and take all these 3 things, put them up top so we can see them. All right, so let's see the order that we have. All right, so at this point in time, we have this hash map, a mutable hash map, or mutable map, that takes a string and item by quantity. We then have a channel, which is the way of publishing new reactive changes to this. And we finally have all items, which we require because we're overriding it from that interface to expose the flow. So what I want to do now is we're going to go ahead and just like replace a lot of these things. So I'm going to drop this. It's going to make errors in the code below, but that's okay. Actually, yeah, we'll do that. And then what I'm going to do here is I'm actually going to go ahead and make all items. I'm going to go ahead and actually just assign it to a mutable Stateflow. So we'll do a mutable Stateflow list item 1. And oh yeah, and then we have to initialize it with a list of. We'll import that. And this is like a really nice way of doing this. Mutable Stateflow is not a flow. However, we're overriding this value. Sorry, it extends flow. So at the end of the day, a mutable Stateflow will end up going ahead and actually extending flow. So when this is exposed to clients, it's actually exposing it as a flow itself. So anyway, I think actually it was definitely saying don't expose one of these directly. But from the way the client will see it, or consumers of this will see it, will be a flow. So we go ahead and have that. So now what's really cool about this is the mutable Stateflow. We go ahead and we just set a value on it, and it'll automatically emit. So you saw it reduces the complexity a lot of what's happening. But now is when an actor is going to come in to be helpful, to process the intentions that happen, and then use the mutable Stateflow to emit those values. So we'll just say here, emits changes, and allows us to set values internally. Cool. So that's what the mutable Stateflow is for, but it's exposed to the flow. So now down here, we have all these methods that are here. Now I have to implement these the way this interface works. So what I can do though now is I'm going to go ahead and comment out. Actually, I just dropped the current implementation completely. What we're going to have to do now is go ahead and implement them through an actor. So all right, let's write the actor first now. So we're going to say private val actor equals scope.actor. Actually, we need a scope, so private val scope equals coroutine scope dispatchers.default. We get all that imported. So we have that. Okay. Android Studio, thank you for the import. So now we've got a scope, and I can create an actor inside of a scope. And like we talked about with the coroutine, you need to have a scope that you're running, a coroutine scope. So inside this actor now, I can basically say an actor is going to process the intention. And then after that, I can just go ahead and create some brackets. So an actor, I can import it. It imports the actor, and I guess I should spell actor correctly. That's it. So an actor is going to take intentions that come in, and it's going to process. So inside this actor, what we want to do is we want to have that for loop. So we're going to say for intention. In channel. Oh yeah. So the channel, so an actor is backed by a channel. So channel is actually, if we click in, it's just part of the actor itself. So for each one of these, we want to go ahead and we want to do a processing. So we're going to say when, because a sealed class is really nice to be able to do when statements to make sure that you actually process everything, all the different variations. So we're going to say when intention, and then we can process each one of these. So first one is going to be is find. So we're going to go through each one of these intentions and make sure we handle it. So first one is find by label. Then what we want to do is process it. I'm going to make sure that's imported. Okay, intention not find by label. So let's keep doing this as we go down. We're going to do upsert, and then we're going to do remove, and finally empty. So what this means is this actor that we've created will take intentions coming in, and then using a for loop. So like it doesn't matter. The channel is the way that we're able to send messages across coroutines. So all this background work is happening. You're passing them in via the channel, and then inside the actor, we're actually just going to process them one by one, and we're going to process them sequentially. So I'm going to format my code. So all right, now we're going to process these. But we're not sending these intentions in the actor yet. So let's step back and do that. So down below, we already have these functions that I must implement. So what I want to do is, and we'll make this one a little bit later because it has the deferred part, which is harder. We'll start with empty because that one is pretty straightforward. So with an empty, what we're going to do is we're going to go ahead and we're going to do, oh, actually I have to create, so okay, down here, actor dot send. I send in my intention, the intention.empty. That's pretty much it. So when somebody calls this empty function, I'm going to tell my actor, hey, here's an intention called empty. That'll go ahead and then call this blocking. Now we don't have a data source backing this. We used to have a map before. So I'm going to go ahead and actually put it inside the actor. So I'm going to put inside of here, I'm going to do a val items in cart. Well, I guess I could have copied this over. Mutable map. String, an item with quantity equals mutable map of. Cool. So now we have this item in the cart. So this is going to, it's typically not great to have something mutable, but if it's inside something protected like this, it's fine. Actually, like one of the things you can do, which is kind of nice, is you can actually write vars inside of here. With functional programming, you really shouldn't be doing this, but if you wanted to, you could use a var inside of an actor because the scope is only going to be within here. It's not going to be touched anywhere else, so it's going to be processed or interacted with in an imperative way. All right, so now we have this item in cart thing that we have backed. So what we can do in the empty is, just like we did before, we can do items in cart dot clear. Cool. All right. Yeah, cool. We can go to that. The next one then is going to be upsert. So with this one, we have a new value coming in. We actually want to do an update. So same thing, actor.send, and this time it'll be intention.upsert. And an upsert requires this value, so item with quantity, and we sent it in. So now up here, when we're processing upserts, we want to go ahead and say items in cart, and then we're going to do upsert, so it's going to be the item. So we're going to use the intention. So intention dot item with quantity, and because you're using sealed classes, it knows what type of on operating on one of these. So it's really nice in Kotlin to do that. Item with quantity. I'm going to do the item dot label. This isn't like the best cleanest use case or whatever, but this is a pretty simple example I had that I could show you. And so what I want to do is I'm inserting and updating at this part in the map. So I'm just going to go ahead and say intention dot item with quantity. So what's happening is I said I want to do an upsert. It's basically getting the key, which is the label, and then it's going to set the value inside that map. So now this is what's backing it. All right, so we're modifying the map here with an upsert. We're modifying the empty down here with a clear. Let's go ahead and do a remove. I'm going to do a copy and paste because it's pretty similar. The difference here is going to be remove. Remove. So this time you're sending the actor, I want to remove it. So what we're going to do is we're going to say items in cart dot remove, and then we send in the key, which is that same really long key. So, all right, and then the last one is find by label. I saved this one for last because it uses a completable deferred like we talked about. So if we do find by label, inside of here, we want to go ahead and send this in. We send it in. This time we have a label. So we're saying, I want to find this item in the database. Here's the label that I'm looking for. So first, we want to do a find. We're going to say, hey, I want to find this by label. The problem is I want to return back this value. All the other ones that we've done before don't need a return value. So an empty doesn't, an upsert doesn't, and a remove doesn't. But this one actually wants you to return this. So if we just send something to the actor, we don't have anything to return back. It just says, oh, I sent something in the channel. What we want to do is we want to create a completable deferred. Completable deferred. So we can create one of those. It's called deferred equals completable deferred. Boom, of type item with quantity. I need to return an item with quantity nullable. So now I have this deferred object. I'm going to go ahead and send in label, and then we're going to do format. So I'm going to add one more item into this, which is a completable deferred. Format. So find by label right now only takes the label. In order to get something back out and to wait for it, we need to send in a deferred object. So we'll send in the completable deferred of type item with quantity. Question. So we send that in. What we're able to do now is down here, I'm now sending the deferred object, deferred, and then I want to return the value. So at the very end of this function, when I need to do a return, I can say return deferred dot await. So hopefully that wasn't too confusing. What we're doing here is typically in the actor, we can just send messages and say, go, 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 go. And it'll make sure it processes those in order. In this scenario, we want to do that. However, we want to wait and get the result back from this. So in order to do that, we're sending this thing called a completable deferred, which is basically a handle that it's going to wait until we've provided a value to it. And when it, so it's kind of like async await on JavaScript. But we're going to go ahead and wait for a value to be set. Once a value is set or it's completed, then this will end up executing and it'll return back. So let's see how that's going to work up in our implementation. So in this case, we want to find by label. So we're going to say item in cart. We're going to look up by the label. So it's the same long thing. Get the label off. Oh, actually, no, it's not. We already just have the label primitive. So it'll just be intention.label. And that's because we were nice enough to just say label on this one. And then what we want to do is we want to find this. So really, it would just be kind of returning this. But yeah, so we want to return it. So we're going to take that deferred object. So intention dot deferred dot complete. So that's how we did it. So let's see. So we have our deferred object that got sent in with the intention. And when we say complete, what that's going to do is tell it, hey, here's the value you were waiting for and you're blocking for. What that's going to do as soon as this code is completed, the one that's awaiting will let it keep, it'll let it continue on, right? So it's completed, it'll take that completed value and return it back to this window. So I think we have most of this implemented now. So let's go up. The thing that we're missing in all of this is this, the ability, okay, so let's talk about what we have first, then we'll talk about what we're missing. So we have a bunch of intentions that represent the sort of things that we want to be able to do to modify the data. We have an actor which processes those intentions. And so what it'll go through, it'll find the intention, which type it is, perform the action on our data source, and therefore be able to operate on it. The thing that we don't have right now is the ability to take the new values, or sorry, the new data object, and then emit that out. And we went ahead very early on and created this mutable Stateflow so that we could actually do that. What we want to do now is we want to emit these out every time a change happens. So the way it works is, down here after the when block, we know we process things. So what I can do is, I can say, this is called just items in cart. So, yeah, it's the mutable, all items, dot. And so what's nice here is we can go ahead and just assign a value because it's a mutable Stateflow. And we could say equals items in cart, dot. And I have a function to this, toSorted list. Yeah, toSorted map. There it is. Okay. All right, I might have to go to my other file here to see. So in memory shopping cart now. What was, as sorted list. So that's the function I was looking for. It's an extension function that just takes this, this map and then converts it over to the list that I need. So it's going to go ahead internally, get all the values, and then sort them by the label. And that way, like, everything's going to like stay the same way in the UI when I display them. I want to make sure that they're sorted that way. So what this is going to do is every time we process, so we're going to wait for messages coming in on the channel. So we wait for messages coming to the actor. Each one of them that we're going to process one by one. Hey, what kind of intention is it? Is it a find by label? Is it an upsert? Is it remove? We're going to then execute the logic that's inside of those. And then as it's all done, we're going to go ahead and tell our Stateflow, which is what everybody's listening to as a flow. We're going to say, hey, here's a new value that's sorted list. So that really should do it. I'm going to be really dangerous here, and we're actually going to see if it works. So I think this is session graph info. So I have this, anyway, this is a manual dependency injection of this. Don't get too much in here, but I'm going to replace the in-memory shopping cart DAO that we have now with our new actor. Is that what we called it? Yeah, actor flow shopping cart DAO. So I'm going to use one of these instead. And what this is going to do is the DAO that we're going to use in the application is actually going to use this now. So run app. Let's see what it's like. So we'll see it flash here in a second if Gradle's. See how it's doing. It looks like it's building now. Let it build. We'll dig back into our code. So when we run it now, it should use our version of things. I don't know how to see progress in this view, but I don't think it should. I'm going to go back out of this view just so I can make sure we know what's going on with our build. Yeah, Gradle build running. We can look at the build here. Everybody loves Gradle build. Okay, it's assembling. It's all right. We can go back now to our app, and it's published it. Yay! So now, is it going to work? I don't know. Hopefully, it will. Gala Apple add to cart. Yay! So you see the top right here. As I add the items to the cart, 3, 4, 5. So it is working. It's emitting the new value with the Stateflow. Pineapple. Go ahead and add a few of those. It went ahead and added them up. And then we'll go here to the cart, and we can see them. Now I want to prove to you it's actually this code running. So what we're going to do is inside of our code, we'll go back into that presentation mode. So inside of here, where we're processing things, I'm just going to put the value that we're emitting. So this is really our new, I'm going to call it new value. And I'm going to do val new value. This. And that way we can just print it out here. So we're going to do just like a log.d, actor, and then we're going to print out new values. I have to import the Android logger. Okay. And then once we do that, then we can go ahead and run it again. And so every single time, actually, let's get the intention going too, because this will actually be pretty cool to see that. Copy it. And so for each intention that's coming through, we're going to print out what the intention actually is. So actor intention. And then down here, it's going to be actor, or I'll call it new values. Sure. So if I go and do that, let's run the app again. And then let's look at the actual log cat that's going to be there. So I'm going to go back to the view, because that's the only way I know how to do it instead of presentation. Next time I do a presentation, I'll make sure I put it in large font so I can do all these things at once, but it's not smart enough. All right, so logcat coming up. So shopping app, here we go. Gradle build running. A lot of stuff happening. Let's see when the Gradle build ends. Yeah. All right, packaging, yay. All right, app initialized. Cool. All right, so now I'm going to clear logcat. I guess you can see this if I put it on the side. We'll put this on the side of my screen so you can see it. So this is the phone I have in my hand that we're using logcat for. I'm going to click on vegetables, and I'm going to click on kale, and I'm going to hit add to cart. So before I do this, I'm going to clear, and I'm going to add to cart. And you can see here it says actor intention. First of all, there was a find by label. And then I guess it's not a data class, so it's not going to print out in really nice. Let's see if I can make it a data class, because that actually might look a little bit better. Data. The one thing I love about Kotlin are their data classes, because you can then, it does a really nice toString. If I run this again, we'll see it. But you did see, like, it went ahead and got an intention, and the new values were nothing. Then it got a new intention saying an upsert because we added it, and then it has one value now. So intention was just fine, nothing, and then we added one, and then we had new value. So it might be because I'm doing 10 things on this computer why it has slower builds today, but it's almost done. There we go, and we'll clear this out. It should relaunch here in a second, and we'll check out that we're actually getting everything we wanted. All right, so now we have our app running. I'm going to clear all this stuff out. We're going to go to seafood this time, and we're going to get some shrimp. So you can. So now I'm going to say add to cart. There we go. So I hit add to cart. First thing it did was it found by label shrimp. The label shrimp coming in and a completable deferred. There's nothing in the cart to begin with. That was just what it needed to display this page. The next thing is, and I'm sorry this is really small. Again, I wish I could probably make it. Can I? All right, we're not going to go into that. But the next thing that's there is, so I'm just going to add a few of these, and then we'll add, and then we'll go back, and then we'll add some lobsters. Add. So what I'm going to do here is a tricky thing. We're going to take this output, and then we'll go back to presentation mode, and then I'll show you the output there. Let's put it in the top of this file. Boom, yay, it's big. Okay, so we'll move over. There we go. So we have it going through. Oh my gosh, it looks horrible. We'll comment it out. There we go. Yay. All right, so we go through. The first thing it needed was display the page. It needed to say, hey, give me the information on shrimp so I could show it. So we went through, label was shrimp. It returned back. I had that completable deferred so we could say, here's the value. Then we did an upsert every time we hit add, because it went ahead and said, oh, here, actually, I want to update the value to say we now have the quantity of 1. If I hit it again, quantity 2, quantity 3, quantity 4. And so now you can see at the end of this, the new values that I'm going to emit out are going to be for label shrimp. I have a quantity of 4. So that's what got put out. That's why the shopping cart item got updated and everything. And then we're going to go down. And the next thing I see here is a thing called a find by label for lobster tail. Because remember, we went back and then we clicked on lobster tail. So it actually had to go in and load that screen. So it said, hey, I need that data for that to render that screen, return it back with a completable deferred. And then after that, I start hitting the add button. So the shopping cart values at that point in time were just the item with quantity. So this is just what was already there, sorry. But after we do an upsert, where we're adding a lobster tail, you can see lobster tails go up 1, 2, because I added 2 of those. But in the actual shopping cart itself, you have now the lobster tail with 1, and the shrimp is 4. So anyway, you get the idea, right? Let's go ahead and take this code back out. It's not really code, just my hacky way of showing you some stuff. All right, so what we've done here is we've done this beautiful marriage of like all of these cool Kotlin coroutines. We're using an actor in this case, and this is a pretty trivial case, but it was kind of a little bit easier to understand. We have an actor. Main thing is messages come in. We call our messages intentions. They process them in a for loop so that we get concurrency. So they process them sequentially, and that way, like, our data is always processed in the order that we want it to. That intention that comes in, it's a sealed class. That's awesome. I can have different types coming in. So I can have a string on this one. I can have an item with quantity on this one. I can have all these options. And then when I go and process it, I process the data, and finally I emit it. There's one thing that's kind of cool that you might want to do, because every single time it was emitting new values. This is even if it went and it just found something, or it would go find something and emit new values, find something and emit new values. And what's not good about that is you're not actually modifying the data, but we're still publishing all these events. So something you could do is, this actually did talk about, and something I didn't know before, I think he said Stateflows only emit distinct by change. So it actually might be all right in that regard. But if that wasn't the case, what you could do is you could say if all items is not equal to new values. So it's actually not all items, it's going to be all items.value. What this is going to do is say all the items that are currently there. Let's compare it to the new values we computed. And if that's the case, then let's go ahead and set it. What this is going to do is make sure that it's kind of distinct until changed by, honestly. It's going to compare, is this a new value? Is this distinct? If it is, then go ahead and set the stateflow, mutable stateflow, which will make it emit. So same kind of thing. But yeah, thanks actually for that tip earlier about stateflows only emitting distinct items. All right, so I think we went through the example pretty well. You have a good idea. If you want to, there is a link in the slide that goes out to this PR and pretty much implements the same thing. Going back to the slides, I think we're just wrapping up now. So, oh my gosh, Stateflow, you told me to use that now. That's experimental Coroutines API. Man, this Sam guy and actually guys, like, they don't know what they're talking about. What are they doing? You know, the thing with Kotlin Coroutines is it's fast evolving. And so they add these annotations on to say like, hey, this is not completely stable yet in some cases. Like Flow, they've migrated to be good now, and they'll continue to do that. But what experimental coroutines API means is that roughly speaking, there's a chance it might change a little bit in the near future, but they're going to provide a way that you can go ahead and migrate to that. So I've previously in the past, in the team I'm on, we used channels a lot in the beginning. So we didn't have Flow. But we wanted to do something reactive, so we used completed broadcast channels a lot. And what we would do is, when those things got deprecated, or some of that functionality got deprecated with receive channels and things, we went ahead and we migrated more to Flow. So there are definitely ways to do migrations there, but just there might be a little overhead on some of these things as you go forward. So the example I showed really showed how you can take an actor and a stateflow and marry them together for something beautiful. Now what I did, in my example, I exposed the stateflow as a flow, so that's only going to be exposed that way. But anyway, they can work really well together is the idea. An actor is not meant to replace a stateflow or a conflated broadcast channel. An actor is there to take messages that come in from different coroutines and process them sequentially so that you achieve concurrency. And then the stateflow and flow objects and channels and things are ways of broadcasting those reactive events. So they're beautiful because they're complementary to each other. They can be used together. The actor provides that thread safety, which is needed for concurrency. And stateflow is a nice data container. So it allows you to emit a flow or to just grab data from it. But it's a nice way to contain that value object that we are modifying. So that kind of wraps it up. Thank you very much. Yeah, I'm Sam Edwards. Feel free to follow me online at HandstandSam. And thank you so much again, the organizers of Android Stream Day. It's been really fun. Thank you.